Hi, and welcome to a little tour of a sketch that I'm about to put on the forum. This is the latest version of the Mk2a PV Power Router, and in particular I want to demonstrate its anti-flicker capabilities because I've got these built in as an option. So this is the top of the code. It's got a tally mode flag, which I'm not using at the moment. Tally mode is a very useful mode for calibration. Speed check is on, and this is a means of ensuring that all of the processing that's intended to take place during the ADC conversion periods is really doing so. And I've now got an operating mode here, which can either be in normal or anti-flicker. We're in normal mode now, so if I just open up the serial window, which is here, and the thing should start running. It goes through the startup, tells you how much energy is in the bucket. It tells you the size of the energy bucket. Owing to the fact that I'm now doing power in whole cycles rather than half cycles, there was 100 in this expression, which is now turned into a 50. But anyway, it's a big number, up in the millions. That's the size using integer maths. Now these zeros that are appearing here tells me that I think it displays every 5 seconds or so. So every 5 seconds it's saying that the number of times that the general processing didn't complete within the available time during an ADC conversion period. Anytime it doesn't complete, we add a 1 to the number. So this is saying that repeatedly every 5 seconds the number of times when it didn't complete is 0, so that's quite useful. So that shows speed mode working, and you can leave that in place quite happily. Okay, so what I've got connected up now, it's not a pleasant day, so I'm not outside in the warm. I've got 2 heaters on the go, so I'm very warm. This is my MagniLab CT, but it works just the same as one of the standard blue ones. Now there's 2 sets of wires going through there. It's a bit difficult to see. But coming straight out of the mains and taking 2 loops around here, we have a connection to a space heater, which the lower setting of which is 750 watts. So because it's going twice through the CT, it looks like 1500 watts. And coming out of the triac, I'm powering another heater. This is a 3 kilowatt heater. So that's set to on, but there's no power because I'm not simulating any PV. So if I put this one onto 750, which times 2 looks like 1500, there we are. We've now got 1500 watts being generated, and after a short delay, which I've missed, hopefully we can see the flickering picking up. So this 3 kilowatt load is running at 50% power, and we're getting significant flicking. Either the triac and hence the load will be coming on 1 cycle and going off for 1 cycle, or it's possible it might be 2 cycles and off for 2 cycles, but it's very quick, and clearly this wouldn't meet any flicker spec. So if I turn this back to off, immediately the system goes off, and while that was happening, I'm pretty confident that we will not have ever failed to get the processing within. I'm actually putting a delay of 10 microseconds in each of the ADC processing times, so oh, that's pretty. What excellent timing. Anyway, what I'm now going to do is to recompile. First of all, I think I'll get rid of speed check because I think that might be a bit confusing, and now all I'm going to do is recompile with operating mode anti-flicker rather than normal. So we take anti-flicker, this is where I need 3 hands. What's that? Control C, Control V. So the operating mode is now anti-flicker. Compile the code, and away we go. There's no particular need to see what's coming up on the serial monitor now, so when it says done uploading, which it does, we just... oh, I don't need to do that, do I? All we need to do now is run the code. So This fire is not on, this fire is not on, and if I switch this one on, we're now generating 1500 watts of equivalent power, and this 3 kilowatt load is now cycling on and off in an anti-flicker mode. So whereas before it was flashing on and off many times per second, it's now cycling at a very slow rate. One of the anti-flicker measures that I've put in there is the requirement that the triac can't come on more frequently than once every 5 seconds. So it is possible that the bucket could be overflowing, and we've now got a little detector for that. I hope this shows. Basically the onboard LED, rather than simply showing when the triac is on, now shows when the bucket is overflowing. So what's happening is just before the 5 seconds is up, at about 4 seconds, the bucket starts to overflow. It can't come on yet, but after 5 seconds the triac comes on, the load, and then the load comes on, and the bucket's capacity, the bucket's level is taken down from maximum capacity of 3,600 joules, or whatever that is in integer maths. It's then taken down to 20% capacity, and at 20% the triac switches off. But because I've got the minimum repetition time set to 5 seconds, the energy bucket, when being charged up at 1500 watts, which is half power, gets to the maximum within the 5 seconds, so there is some overflow. Now, one way to show that this only happens at half power would be to simply change the fire. Now I have no lower rate than this, so what I could simply do is slip out one of the loops around the CT. So if I can just do that, work out which way the CT is, slip out one of the loops around the CT. So I've done nothing other than simply alter that. We're still on, so we're now only generating essentially 750 watts. This should still be cycling. We're off now, we're coming on, but it should take, because we're generating less power, this should be off for more time than it's on now, and within the 5 seconds I think it's unlikely that we'll be getting to the maximum. So I think now we're getting full operation without overflow, but we can come back to here and have a look. That looked like a little flick. Okay, so we're getting a tiny little flick. This tells me that the bucket is hitting overflow fractionally before the 5 seconds. Looks like sort of 4 3/4 seconds. That was purely by chance. But a 5 second is a very stringent anti-flicker requirement. I think 3 or 4, maybe 2.5 would be fine. So in all practical circumstances the amount of overflow would be very small, but this does show the system working quite nicely. Now I deliberately didn't have speed check on, because every time speed check outputs its number you get a little flash on the transmit LED, which is quite close to the onboard LED pin 13, but there are of course 3 separate LEDs for, I think it's zero communication either way, and the onboard one for pin 13. So I think this shows what's going on. If I were to lean down while we're looking at the overflow and simply turn the fire off, then we should see no more, because the bucket will never fill up. Now I can actually put on a higher rating of fire. This is 11 something, so we might well now see the thing start to come on. There we go. So we're generating 1100 watts of PV, and we are seeing this overflow situation. If I put them both on, so I've now got a 2 kilowatt worth of PV being generated for a 3 kilowatt load, and we are seeing some overflow. Now the overflow is not more than 1 second in every 5. So if the 5 second requirement was actually 4 seconds or 3.5 seconds, then there wouldn't be any overflow. So this significant anti-flicker measure would not be affecting the efficiency by which we divert power. So I think that's how it's working, and there's a nice picture of the Cosmos to finish. So thanks for watching, cheers for now.